We'll get started with today's lecture. Today's our third lecture, and we'll be talking about relational databases. And yeah, so the quick announcement before you begin about just like tomorrow. If you've probably seen already, like classes have been canceled. But since your assignment is still due on Wednesday, Mateo and Isaac will be holding office hours online if possible, or at least Mateo will be holding them online. So you guys can hop on a Zoom and get help if you
I'll
guys need
send
it.
a Zoom link in Ed like as an announcement tomorrow.
Okay. Yeah, so still due on Wednesday, but you can still get help tomorrow if you want. And assuming that like Wednesday stuff isn't canceled across campus, there are office hours on Wednesday as well from 4:30 to 5:30. So make sure to pull up if you need some extra help before this Wednesday. And you can find our office hours on Ed and on our syllabus in the textbook. Okay, so before we get started with today's content, let's just quickly go over some review from what we've like seen in the course so far, right? So first, we talked about the client-server model in which the client and the server are both computers, right? Where the client runs front-end code and the server runs back-end code. The client sends servers a request. This triggers a route or hits an endpoint in our backend. Some business logic and operations are done. And then the backend server might need to retrieve some data from our database in order to do those business operations, right? And that's where the information from our second lecture comes in, where we talked about SQLs. We're talking about SQLs as well as SQL commands to query data from our database or do some kind of like data manipulation with the thing that actually like stores our data, which is the database. Then after we do that business logic computation in the backend, the server then returns a response back to our front end, right? As you've probably already seen a lot in the demos that we've been doing, as well as in your first two assignments. So this is the picture of like the whole sort of chain of operations that we've gone over so far. So again, we have like the front end sending something. So the server and database combined together are sort of like our backend so far, right? So we have the client here, the front end, sending stuff to our backend, the backend perhaps needing some kind of data, needing a place to store that data, working with the database, doing that business logic, doing those operations, and then sending stuff back to the front end. Oh yeah, so again, here's the chain of, I guess, commands from going from the front end to the back end. And then last week in particular, we worked with a single table database, right? If you remember sort of like the demonstration from last week, as well as a lecture from last week, we made a to-do sort of app, like a to-do list sort of app, but we only had one table, which was tasks, right? And we put in like a task name, a description for the task, as well as a Boolean for whether or not the task was complete. We structured this information into rows and columns. And remember that for each of the columns, we define a unique type for it. Like, for example, like I mentioned a little bit earlier, whether or not the task was complete, we set it to be a Boolean. The ID we set to be an integer. In the description and the name of the task, we set to be a string, or at least in SQLite 3, the database we're using, it was like a text. So we define specific types for each of our columns. And remember, we talked about how a row in the database is particularly an entry in the database, and it represents a specific value. So in our case, it would represent a specific task that we put into the database, right? And then we use SQL commands and queries to get this data from the database or manipulate this data or put data back into the database. So this is what we've covered in the course so far, right? We've covered like routes to databases, which are like the fundamental components you would need to create and sort of like build your app. So let's kind of like review the assignments that you've done so far and kind of understand where we're going with the content that we're going to be talking about today. So if you think back to your first assignment, PA1, there were two particular like issues with it, right? First being data persistency, and second being like a really clunky and sort of awkward way of implementing like comments and posts. If you remember from PA1, what happens after you refresh your app and then try to like hit postman again? Like, do the posts sort of like stay, or do you have to like make new posts? Yeah, you had to like make new posts, right? Which is pretty annoying. And then additionally, we also had like a lot of just like general questions about like how do we, implement comments and posts when there are clearly two sorts of like ideas that should be like linked together. So if you remember from PA1, we fixed this data persistency issue by implementing databases in PA2, right? Which is the project that you're currently working on right now. Now that we have a database, we don't have to worry about your data sort of disappearing every time you restart your app, because at least for us with SQLite 3, it's stored in a file, right? So this is how we implemented comments and posts from PA1. We just made two Python dictionaries in app.py, which is very unideal for us if we want the data to stick around. And now we have a db.py file that we sort of work with to ensure that, these things don't disappear for us and it's actually stored for a very long time, or as long as we particularly want it to be stored. But that only addresses the first problem, right, about data persistency. We still haven't fixed the second problem of how can we find a better way to implement posts and comments so they're not just like two Python dictionaries where you sort of like link the keys of the dictionary together, right? Is there a way that we can actually use our database that we've been using to help us store the data in order to link these two things together and make the connection more apparent? So that's what we're going to be talking about today. Does anyone have any questions on anything I've went over so far? Okay, so yeah, let's hop into how we can actually like fix this problem of connecting, for example, posts and comments, or maybe two other concepts in other apps so that it's not very clunky and awkward like we did in PA1. So today we're going to be talking about relational databases. Okay, so as a brief overview, right, as the name sort of implies, a relational database essentially allows relationships between data. Like I was sort of hinting at when I was talking about posts and comments that seem to be two things that are just pretty interconnected with each other, you can sort of imagine them as being in like a relationship with each other, right? Essentially, when you have things like posts and comments in your app, you might ask things like, which comments belong to which posts, or for example, if you're using an app like Facebook or like Instagram, you might ask like which users are friends, right? So you have things in your app that are just by logic and sort of like using common sense, it's implied that they're sort of connected or linked to each other in some way. In the app that you're implementing right now with PA2 or like mock Venmo, you might ask like, which transaction I make is related to a particular sender or a particular receiver. So let's think about like a users and posts, right? So if we're using like for Instagram as our particular example. So here we have two tables. We have a user table and a post table. And the users are me and Mateo, and the posts are potentially something we'd post on Instagram or some kind of social media platform. So we can actually use these tables and sort of like the properties given to us in these columns to potentially like link who made which post and kind of link the users to the post that they made. So for example, the first post in the post table has a column called user ID. And as it might look like, that user ID would be associated with a person here in the user table. So for example, personally, I would not stand for this has a user ID of 2, which means that Mateo over here with a user ID of 2 was the one that made that particular post. This concept, as just like an abstract term for it, is called a foreign key, right? So if you might remember from our first lecture, we talked about a primary key. So going back to these tables, right, like this particular ID field here would be the primary key because it distinguishes, which entry is like the particular entry in this user table. But that post table over there, the user ID is a foreign key because it references this primary key column. So you can link the two things in these tables together. So just as like this thing is called a primary key, you can also call a foreign key a secondary key, just if primary and secondary are like easier to correlate and understand. So yeah, like the slide says, we saw that the user ID field, refers in the post table, refers to which particular user that it belongs to. And essentially, you would use these foreign keys to define relationships between two particular like concepts or entities in your app. Does anyone have any questions on a foreign key? Okay, So if there are no questions on like the concept of a foreign key, we'll be sort of using this idea of a foreign key as the foundation to build our understanding of potential relationships in a database. So going on to the three relationship types, there are three main ones that you'll be working with, right? So first is a one-to-one relationship. Second is a one-to-many relationship. And lastly is a many-to-many relationship. Wait, I realized I didn't turn my camera on in Zoom. Oh, wait, it is on. Oh. Okay. Okay. So yeah, there are three particular types of relationships that we'll be hopping into. So first, let's talk about a one-to-one relationship, right? So as the name implies, for a one-to-one relationship, it literally means that in the two tables that you make, one row in the first table would correspond directly with one particular row in the second table. So more abstractly, we have row X in table A is exactly one row Y in table B. And that row Y in table B also has to directly link back to that first row X in table A. So a great example of this would be students and net IDs. Note that like everyone at Cornell has a unique net ID. So if we had a table for students as well as net IDs, you would only expect, one student to be linked with one net ID and one net ID to be linked back with one particular student. Let's look at a visual example of this, right? So we have a users table and a net ID table. So for users table, again, we have me and Mateo. And the net IDs table, we see that Mateo's net ID, MAW346, is linked with Mateo here because in that user ID column, it has a field of 20, which links with Mateo's ID of 20, right? And with my net ID, JYW55, the 10 in the user ID table links with the 10 that we have here in the user table. The SQL command that you would use to create this kind of relationship in your database would be like sort of as follows. So first, you would obviously need to create the users table, right? You would define your primary key, which is the ID. You would define the field for name. And then you create a second table of net IDs, right? Which is like a new concept or entity in your database. Remember how in the second lecture, we talked about that a database isn't one particular table, but rather it's a collection of tables. And we kind of see that illustrated here where we can have multiple tables together linked in these relationships, right? So when we create the table for net IDs, we have the ID, we have your net ID, and then we have a field to reference back to the user ID from our users table, right? Here we like specify that this user ID, first of all, has to be an integer because we're referencing the user ID on the other side, which is an integer. But then secondly, it has to be unique, right? Since we're enforcing that this is a one-to-one relationship, it means that you can't potentially have duplicates in that second table, or else it wouldn't be one-to-one anymore, right? So everything in this net ID table has to be unique. Just thinking of it as like, every potential student has a unique net ID. Then to sort of define or to tell our database that like this new column that we made for user ID is a foreign key and it's supposed to reference something in the original table, we use this last sort of segment here. Foreign key user ID references user at ID. So this foreign key keyword essentially tells us that like this column user underscore ID will be the foreign key. And then references keyword essentially tells the database which column to look for in the entire database to reference to, right? So the way we define this here is we have users like parentheses ID, where users is the table that we're looking at, and then the parentheses ID is the column in that particular table that we're looking at, right? So in essence, we want the second table net ID to reference the ID column in the users table. Does anyone have any questions on that? Okay. Oh yeah.
For users, we say users like a function or oh, is that the table users and then the oh okay.
Yeah, exactly. So we're referencing the table called users that we made up there, right? And then we specifically want to look at the column ID. Yeah. So for example, let's like hypothetically say you actually want to reference like the name column, you would just do users like parentheses name, right? Okay. And here we can like insert values into our table again. So for example, if we want to insert into the users like Joyce, suppose this is like the first thing that we put into our users table. Then if I want to put my own net ID into the other table, then I would insert into net ID like my net ID as well as the user ID to know that like that net ID would correlate with me, who has an ID of 1. Okay, any last general questions on one-to-one relationships before I move on to one-to-many? All right, if not, let's talk about like one-to-many relationships, right? So in a very similar vein as one-to-one relationships, a one-to-many relationships, a relationship is just that like one particular row in your first table might be corresponding with many rows in your second table, right? So abstractly, we have row X in table A refers to many rows in table B. So it could be like Y1, Y2. But if that specific like row Y in table B only corresponds to one row in the first table that we talked about, which is table A. So as an example, you know, like for example, sports teams, like baseball teams, they have a lot of players on them, right? But like each team would have a lot of players, but one player, like any particular player can only belong to like one team at a specific time. So that's like a real life example of a one-to-many relationship. So if we go into these two tables here, let me move my camera. Oh, well, I don't really, the cursor isn't showing up, but basically those are the players, right? This is not the users, but like the teams table. But essentially, here we have like team names, and we have like the players on that particular team, right? So these first two players play for the Los Angeles Angels, right? There's a TA over there that really likes Shohei Ohtani, so you can talk to him about it. But yeah, so we see that there are multiple entries in the second table here that refer to this first entry in the teams table. Similarly, there are multiple entries on the players table that also refer to the second entry for the New York Yankees on the team table. So this is essentially the implementation for a one-to-many relationship. Are there any general questions on this? Okay, if not, then we can kind of talk about the actual like SQL commands to implement this as well. So very similarly, one particularly unique thing you can do with one-to-many relationships is that potentially you would want to be able to retrieve all of the associated like many for that particular one, right? So contextualized to this example, if we have like the teams as well as the players, we would potentially want to be able to get all of the players that are on a particular team. And the way that we can do this with the way that we have set the tables up is very simple, right? We would just need to select star, so select everything from the players table where the team ID is the specific team ID that we want. So hypothetically, if we wanted everything from the New York Yankees, we would select star from players where all of the team IDs is 20, which is the one associated with New York Yankees. That way we can get everything from the players table and get that only sort of like are associated with the particular team that we want. To actually like implement this with the SQL commands, we would want to, again, create the table of teams, have the ID and the team name. All the setup for the original table is pretty similar to what you've seen so far. But then when you create the players table, it's also very similar to what you saw with the one-to-one relationship, right? You would define everything needed for the players, that be like ID, name, still needs a primary key, right? But the only difference is here. So in our foreign key table, whereas before in the one-to-one relationships, we just enforced that it was unique, here we have to enforce that it's not null. Basically one step down from unique, right? So here we don't actually care whether or not the foreign key is unique or not, because we don't need to enforce that like exactly only one exists. We can enforce however many one exists, potentially in like that secondary table, which is why we take a step down from unique and just implement not null. But here we still need to define that the foreign key references that particular team. So this part looks exactly similar to what you saw before, where we define the foreign key and we say which column in the original table that it references. Any questions? Okay. Oh, so this is just a comparison to the one-to-one that we talked about before. Again, notice that here it's unique, whereas here it's not null. Oh, okay. So lastly, we'll move on to a many-to-many relationship, right? Oh, yeah. Yeah, for sure. So essentially, right, for a one-to-one relationship, in the secondary table, you can think of it as like when you force a one-to-one relationship, there has to be a unique relationship between the two, right? Like my net ID is unique to me. So I can't reference another like person when I'm doing a one-to-one relationship. But for a one-to-many relationship, we can take like a step down from unique, right? Like if we have like multiple players on like the baseball team, for example, they would probably all reference the same team. So they need to have that same number in that foreign key column. Okay, so now finally, let's talk about a many-to-many relationship, which I guess like by the sounds of it is also a little bit more complex than the other two. So as the name implies again, the many-to-many just means that like we have many rows in our first table that might refer to many rows in our second table, and many rows in our second table might refer to many rows in our first table. And a great way we can think about this is with students and courses, right? So we have one student that can be in many courses, but each course also contains a lot of students. So how might we actually represent this in our database, right? There are three potential ways that we can implement a many-to-many relationship in our database. First, we can store multiple columns to just have a whole bunch of foreign keys. Second, we might have just one column and then store like the IDs that we want to reference to as like some kind of like list or array, right? And then lastly, and since it's presented last, it's probably the best option. It's a join or association table that sort of mashes two tables together. We'll kind of go over why the first two are not ideal and why the third one would be the best option, but we'll kind of go over how each of them will be implemented. Any questions before we start? Okay. So let's look at like the example of students and courses, right? So we have students. Again, I'm JYW55, Mateo is MAW346, and these are all the courses that we're enrolled in. So I'm in 1110, this class, and 2110. Mateo's in 1110, 2110, and 2800. But you know, what happens if like a student potentially is enrolled in like more than 3 courses, right? So let's add someone new into the database. Let's add Isaac into the database, who's over there. And let's say he's just like absolutely stacked and is taking like 5 courses. But then like, it's kind of like weird, right? Even in this like visual example, like why is there just empty space in like me and Mateo's row? So what do we do there? Well, one potential option is that we just might add like null for like each of those columns, right? But does anyone have an idea as to why this might be pretty bad? Yeah. Yeah, exactly. Like if there's just one guy that just has so many more than everyone else, then you have way too many nulls in the table, which would make it really space inefficient, right? So let's say like Kate, for example, is only enrolled in 1 course compared to like Isaac here. She would have 4 null values, which makes our database really, really big, but like storing a lot of nothing. Yeah, so that's the reason why this would particularly be bad, because it would be space inefficient. So next, let's talk about the second option, in which where we store the courses that someone is enrolled in as some sort of like list, right? So again, in a similar example, me and Mateo are here, and we see that here we have a course table that has 1110 and 1998. So we have students 1 and 2, pretend like that's some kind of like list and has like brackets in it for both of us, and then just 1 for the single person that's enrolled in 1998, which is myself. Okay, so let's say we have Isaac again, and he's also enrolled in these courses. Well, how would we actually like add these courses into our second table, right? Well, the way that like you could potentially do it in like just like thinking about it in like Python is you would have to go through that list and just like append Isaac's ID here into the list of students, right? Which means that you would have to go in and iterate through the entire list to sort of like change what's going on there. So here we add a 3. Oh, that's pretty bad. Because again, if you think about it, right? What if like our lists get super, super long, right? So we already have like a whole bunch of people enrolled in 1110, as well as like CS 1998. So 1110, has like 400 or 500 people like per semester in it, potentially, right? Does that mean that we would want to like iterate through all 400 or 500 entries just to add like one more person into the class? Well, if we think about it like that, then we figure out that this method is pretty time inefficient, right? Because it means that we have to do a whole bunch of iterations just to add in someone new, which is also pretty bad for us. Any questions there? Okay. If not, let's go through like the best way to actually implement a many-to-many relationship. And that's more time efficient and more space efficient is if we use a join or association table, right? So essentially what we're doing here is we're just mashing these the student table and this course table together such that we create a new table that just links the student IDs and the course IDs. So in this table, you notice that this first column here is linked with a student ID, and a second column there is linked with a course ID. So we can figure out, which student is in which course, because they would all be entries in this particular table. So we see that myself, JYW 55, I'm in 1110 and CS 1998. And we just link it to the course ID such that we have this completely new table that we can like query our relationship information off of. So if I'm curious about like, for example, which students are enrolled in 1110, I can just do a SQL command on this join table in the middle here to get out all of the student IDs, and then we can link it to the particular students. And then similarly, like a visual example, if we wanted to know who's in 1110, we can look for it this way. And then the previous sort of like example here is that if I wanted to know which classes like I'm particularly enrolled in, I can just query this middle table again and look for all of the particular course IDs. This also makes adding something new a lot easier, right? So instead of having to like either add a new column or like iterate through a list that might have 400 entries in it, we can just simply add a new entry into the database, which obviously is a lot more, I guess, like time efficient for us because like databases are sort of implemented in a way where adding something new into it is a lot more time efficient than just iterating through a list. Yeah.
So like, what if instead of like using a list, like you use like a set or a hash map or something, and you wouldn't? Is there some way to like integrate that so that way it would still be like efficient?
Yeah, I mean, potentially, like, I guess, like, if you used a set, for example, right? The problem with that is that, like, since sets are sort of like, you can't have like duplicates in them, that might like, in terms of like a many-to-many relationship, it might like defeat the purpose of like a many-to-many relationship. You could potentially also like implement it with a hash map, but then you would have to think about like how like exactly what kind of like keys and values you would use to like define these things, right? Whereas like just making an association table like this, the database would handle a lot of this like, since you have a new table, the database handles like the linking for you. So you also sort of just save like in terms of like mental energy as well.
Is it still like most efficient?
It technically would be the most efficient way. Just also because like I think like in terms of like the way like under the hood, the way the database is implemented, querying it as well as inserting things into it is a lot more like time efficient this way. Any other questions? Oh, okay. Yeah, so just quickly going over through like how you would like implement this with SQL. So you would create your table, these two tables, and then you can create a third table, which is like the join table, right? And then you have the course ID and the student ID that you both define as foreign key, and you tell it which one it references. Here you have two foreign keys that reference two different things, right? So first you want to reference the ID in the courses table, and then you want to reference the ID in the students table. Any questions on this implementation? Okay. If not, we're going to move to a quick demo.
All right, everyone. So this is a re-recording of the second half of the lecture where I demoed some SQLite in the terminal. So to recap, I'll be going over the three types of relationship we have: the one-to-one, the one-to-many, and the many-to-many. Yeah, so we'll just start in the terminal. If you remember, we start with SQLite 3. And then first we're going to create a table of users. So this one-to-one relationship, we're going to have users and profiles. And so obviously every user has a profile. So in this case, we're going to have like a user with a name and then a profile with a net ID. And so one name can only have one net ID and one net ID can only have one name. To start off, let's create our table. So create table of users. We want to give it the ID. This is integer, primary key, auto increment. We also have the name. We'll just have this as text and not null. And we need our semicolon to finish it off. And if we do dot tables, to the users table. So the next table we want is the profile table. So again, create table profile. Again, we'll start off with an ID, integer, primary key, auto increment. From there, we're also going to need a net ID. We'll just say this is text, not null. And because this is a one-to-one relationship, we need a user ID to have that connection between a profile and a user. And so this is an integer, and we want this to be unique. And the reason why this is unique is because every profile can only have one user ID. So if there is another profile being made and the user ID is already being used, that should not happen. And so this will prevent that situation from occurring. And then lastly, because that unique ID references a different table, we need the foreign key. And this is the syntax for that. References, and then the table name, followed by the column name. And then finish it off with a semicolon, do dot tables. We see we have those two tables now. So let's start off by inserting a few values into our users. So insert into users name, and we want to give it values. I'll insert my name. Next, I'll insert Joyce. And now if we do select star from users, we can see that we have me and Joyce in here. Next, we'll create two profiles. So now insert into and now profiles or profile. And we're calling the columns net ID and user ID. We'll give it values of, well, for me, it would be MAW346. And then my ID is 1. And then for Joyce, JYW55, and she has an ID of 2. So now when we select star from profile, semicolon, we see the ID number at the start, then the net ID, and then the ID of the user ID, or the user's ID. So now what happens if we try to make another profile and have a user ID that's already been used? Let's say we want to put Shungo in here. So SN, oops. Let's say we want this to reference ID 1. But what will happen is it'll have this unique constraint failed because that ID was already being used. So that's why this user ID integer unique enforces that it's a one-to-one relationship. Okay, so now for one-to-many, we'll assume that users can have many posts, like on Instagram or something like that. So we'll need like a posts table, and that posts table will reference whatever user posts it. And so in this situation, again, we want to create our table. We'll call it posts. we have the ID, is integer, primary key auto increment. We're gonna have, let's say, a post description. We'll say it's text not null. Then we need the user ID. And so this is integer. Instead of having unique here, it's going to be not null. So the reason for this is that the user ID no longer has to be unique. Because a post can be created by a user many times, I could have two posts and those both would have me as the user ID. And so I don't want that to be unique. I just want it to be not null so that there is a user associated with it, but not necessarily that a user only has one post. And so again, this is a foreign key. So we need that last line. Foreign key references users ID. Oh, I think I forgot closing parentheses. So create table posts, ID, description, user ID, foreign key. There we go. So now dot tables, and we have posts, profile, and users. So now let's say we want to insert a few posts. So insert into posts. We have description and user ID. We want to give it values of, well, we'll say I love Max sandwiches, and I need my user ID to post this. Okay. And then let's say Joyce wants to post something. So we'll change the user ID to be 2 for Joyce. And then let's say Joyce is saying Mateo only thinks about food. And then lastly, I'll have another post where I say, I love soccer. So now if we select star from posts, we should see these three. And if you see at the end, it shows the user ID that it's referencing. And so this represents the one-to-many relationship. And there's also queries we can do that have constraints with them. For example, select star from posts. We can say where user ID equals 1. So in this case, it would find all of my posts. So using that where keyword, we can filter those. And so you see we get the 2 that I posted. I love Mac sandwiches and I love soccer. So that represents the one-to-many relationship. Just to be clear, the table with the many part of it is going to have the foreign key, because that's always just going to be one column that just references. In this case, the post will always have a user that it references. So the posts will have the foreign key, whereas the user will just be getting referenced. And so if you want to find which posts the user has, you'd have to go into the posts table to do that. And so next we're going to look at a many-to-many relationship. And so this is the most complicated of the 3. And if you remember from the lecture, we need to create an association table when we do this. We'll first start off by introducing the situation. Let's say we have users that have have one-to-many with posts, and then posts have a many-to-many with hashtags. So for example, my post about I love Mac sandwiches could have many hashtags on it, but those hashtags could be used for more than one post. So in that situation, it's a many-to-many relationship. And so to start, we'll first create that table called hashtags. Let's say create table, hashtags, ID, integer, primary key, auto increment. We'll have the name of the hashtag, and so that'll just be text not null. And then we just need to finish that. After you dot tables, we see that hashtags table there. But that's not all we need. We need the association table. And so association table is just what we call that like middle table between two many-to-manys, but it works the same way as any other table. So again, we're going to create table. Then we're going to call this one feed, like maybe this is like your Instagram feed. And again, we're going to start off with ID, integer, primary key, auto increment. But then this is a many-to-many. And this is the association table for the many-to-many, so it has to reference two different tables. So first we're gonna have a post ID, because the many-to-many is between posts and hashtags. So the post ID will be integer, not null. Then we're also gonna have a hashtag ID, which is also integer, not null. And so it's not integer, not null, rather than integer unique, because again, we want to be able to reference many post IDs in this table, not just one. And same with the hashtag ID. And so because these are both referencing a different table, we have that foreign key. Post ID, references, posts, and column name ID. And then the same for hashtag ID. So hashtag ID references hashtags ID. With that, we can put the semicolon and end it. And if we do dot tables, we see now we have feed, hashtags, posts, profile, and users. So let's start off by first creating a few hashtags. So we're first going to insert into hashtags. And there's the name that we want to put into, and we'll give it values of, we'll start off with food. Then we want to do maybe pool, it's another hashtag. And then lastly, we'll do sport. So now we have these three hashtags in our table. We'll see that we have them all. Food, cool, and sport. Okay, perfect. So now how do we actually link a hashtag to a post? So that's what gets done in our association table. So before we move on, let me just make sure we have all our posts. Yep, so we have I love mac sandwiches, Mateo only thinks about food, and then I love soccer. So to actually create the links between hashtags and posts, that's where we insert into in the association table, and we're inserting into it the post ID and the hashtag ID. And then we have to give it the values. And so this might be a little bit tricky, but you kind of have to map what post you want to have with which hashtag. So for this I love mac sandwiches, that's post ID of 1, and we're going to give it a hashtag of food, which is 1. So we'll give it values 1, 1. Then let's say we also want to give it a hashtag of cool. In that case, we'll give it values 1, 2, because the first one references the post I love mac sandwiches, and the 2 is for that cool hashtag. Let's do Joyce's post. She says Mateo only thinks about food, so we'll give that one also a hashtag about food. And then I made a post about soccer, or yeah, I love soccer, so we'll give that post ID 3 with a hashtag of 3 for sport. And then why don't we also just give it a hashtag for cool, it's soccer. Okay. So now if we select star from feed, we should see a bunch of numbers. Yeah. So the first column is the ID. So that just increments upwards, 1, 2, 3, 4, 5. The second column is our post IDs. And we can see that this is in the order that we input it into our table. And the last column is the hashtag ID. And so from here, we're actually able to like understand what posts have which IDs. And so in this last section here, I'll be writing out some SQL code, which will show you how we can actually like turn this kind of illegible table into like a readable format. It'll show the powers of SQL. This is outside the scope of the course, so you don't need to understand what this means. But I just kind of want to show why SQL is cool and why it's really useful to organize data in this manner. So description. So we want to get the username, the post description, and the hashtag name. all together. Oops, it's reversed. Feed. And then we want inner join. I meant to capitalize on there. On is actually a keyword here. So the result of this should be a much more readable table. So you can see that it's actually queries the user's name, then the description of the post, and then the hashtag name. And so we get everything from our feed here, but in like a readable format so that we can actually understand what our data is telling us. And so that's just one of the really cool things about SQL. I hope you guys enjoyed learning about the different types of relationships and how those get modeled in SQL. So we have the one-to-one, which you can remember by having the user ID or whatever the foreign key is unique because it's a one-to-one. Then there's a one-to-many, which just has a foreign key, but it's usually just not null. It's not supposed to be unique. And in the many-to-many, you need that third association table, which just takes in ID values from the two tables that it references.